So now you understand 5 streams. 5 streams were being taught by different teachers and different coverage. That okay? So now for today, time, because we had begun on the measurements, we had looked at area, length, mass, some streams volume. Is that all? We have another measurement which is supposed to be time. Then we move. Now, I want to tell those students who have not yet looked at volume that before we go to density, when we are going to density, we will first handle volume because we need volume when we are studying density. So today, let's all do time at once. Are we okay? Now, we have a physical quantity called time. You always use this word time, all the time. All the time. What time are you coming? What time is it? What time is the lesson? What time is the lesson? Okay? We always use this word time. What is time? What do you think time is? Okay? Can I see messages, plans? What is time? You always use this word. What time is it? Break time. What time are you coming? What time will they pick me up? Time in simple words. Which English words do we use to describe time? What is time? Now, those who have the NCDC book, the prototype, the student's textbook, we open page 20. We open page 26. Open page 26. Hello. Yes, mother. We open 24. Let's open page 24 for those louder. I can see someone, Karun Johanna is telling me, time is the period between 2 events. That period between 2 events. We are looking at time. Time period spent doing something. Thank you, Nicole, from 1 South. Nicole, we are looking at time. I'm asking, what is time? What do you understand by time? We have those English words that we normally use to describe time. What are those words? What are those words that we use to describe time? Someone has told me time is the period between 2 events. Very simple. One of the English words is period. Another word can we use to describe time? Duration. Thank you. Is this one? Is it Gloria? Gloria from 1 But it's a duration. It's an English word we describe time. Duration. Your exams normally put duration. How long will it take? Time is the progression of events from past to present into future. All that is time. Progression of events. Thank you. There's one other word that I'm looking for. An obvious word. What the clock reads. Very nice. So you can only tell time using a clock. Time is the duration from now till infinity. That is Leila. Continuous. So we have a word that to describe time. How long? How long? This is another word we normally to describe time. How long will the paper take? How long is your journey? How long is this? How long is this? There's that English word that we normally use to tell time. Thank you everyone for your contribution. So today we are looking at time. as a physical quantity in physics. As a physical quantity in physics. Someone else assure time is how long you take to do something. Very time. Thank you so much. So we're saying time is a physical quantity. When we began physical measurements, we looked at types of physical quantities, didn't we? I remember we looked at types of physical quantities. What are those types? What are the two types of physical quantities? What are the two types of quantities that we looked at? We have two types of physical quantities. What are those two types of physical quantities that we looked at? Because we want to find out where does time fall of those two types. Where does time fall? I want to remind us the two types of physical quantities. We must have looked at them at the start. Thank you so much, Nanyonjo Hadija. She's fundamental quantities. Very nice. Fundamental, the types of physical quantities. Nanyonjo has told us we have fundamental. Someone to remind us the other one. Derived quantities. Thank you. I'm receiving so many answers. We have derived quantities. We say these are the quantities we use to obtain the other quantities, don't so? Basic quantity. Someone is telling us basic quantity. Fundamental quantities or quantities. Is that okay? Okay, thank you. Okay. She's raising up her hand. So someone to define for us fundamental quantities. Fundamental quantities. Martha, unmute. Martha, unmute yourself. You can Martha.
Yes. I just wanted to give an answer of the previous question.
For the previous question?
I just wanted to give an answer. Yeah?
Which question?
Types of physical quantities.
Types of physical quantities.
Yes, the answers were already given.
Already given. Okay, so can you define for us any of those? Okay, let's get someone else. Thank you, Martha. Someone to help us find any. You can choose.
Fundamental quantity is the independent physical quantity that is not possible to express in other physical quantities.
It's a physical quantity that is not able to be expressed in terms of other physical quantities. Thank you so much. Thank you so much. She's saying that quantity is a physical quantity which cannot be expressed in terms of other physical. How the derived physical quantities? What are they? Derived physical quantities. Derived physical quantities. Connecting. Please, Martha, help us and you unmute yourself. Martha, unmute yourself. People, after submitting, those people who have put up their hand, unmute yourself. Martha, thank you. Okay. So who is defining derived physical quantities? Okay. So derived physical quantities, these are quantities which can be got by combining other physical quantities, which can be after combining other physical quantities. Now, where does time fall? Which type of quantity does time fall? Does it fall under the fundamental physical quantities, or does it fall under the derived physical quantities? Where does time fall? Where the time falls under fundamental quantities. Thank you so much. Thank you, Daniela. Thank you, Helen. Time is under fundamental quantities. We say under fundamental quantities, we have quantities like mass, which you have already looked at, length, which you already looked at, time. Now you're looking at time today, okay? We also have other quantities like temperature under the fundamental quantities. Safina, can you hear me now? We also have current electricity. As reminded, that's another fundamental quantity. Current electricity. Current electricity is also under fundamental quantities. Thank you so much. Now, today, one of the fundamental quantities we are looking at is time. We have defined time, how long an event takes, the period between two events. People have given me very beautiful answers about time. How about SI unit of time? What are the SI units of time? What is the SI unit of time? Seconds. Thank you so much. Thank you so much, Helen. Thank you so much. Oh, someone has given me sec. Sec does not exist. Sec does not exist. It is either second, or if you want to write that short, the symbol, it is second, or a small s. A small s. We either use seconds in full or a small s, and the s should really look small. It should not be debatable. That this is a 5, this is a capital S. Let it be a small s. So the SI unit, Pauline, the SI unit of time, the SI unit is seconds. Is that okay? The SI units of time is seconds. How about now the other units that we can use to tell time? Other units that you can tell time. Hours, thank you so much. Minutes, thank you so much. Days, thank you so much. How many days? Which weeks? Yes, thank you so much. So we have hours, minutes, days, years, months. Okay. What else? Any written on the blackboard? A decade. Thank you. A decade. Decades. Centuries, microseconds, millenniums, generations. Wow, beautiful answer. Thank you so much. Thank you so much. Nanosecond. Thank you so much. All those are units that we can use to tell time. Can we change from one unit to another? Jubilee, someone is telling us Jubilee. Now, can we change from one unit to another, or any of those units to the SI units? Can we change any of those units to the SI units? For example, how many seconds are in 1 minute has 1 minute has how many seconds? Okay. 1 hour will have how many seconds. What else? 1 hour. Or even 1 day has how many hours? 1 year will have how many months or even days? How many days? Any of those? Yes.
1 minute.
1 minute, someone is telling us 1 minute has 60 seconds. Thank you. How about 1 hour? 1 minute has, please let's avoid the word sake. Someone is telling us 1 hour has 3,600 seconds. Thank you. 3,600 seconds. 1 day has 24 hours. 1 day has 24 hours. 1 day has 24. 1 year has 365 days. 1 year has 365 days. How about months?
12 months.
1 year has 12. UTC. That means we can change any from one unit to another. Is that okay? Let me give a question. Let me give a quick question so that people can help me calculate and post their answers. Okay? And post your answers. Maybe let me speak. Video, okay. Convert the following into the SI unit. Convert the following. Convert the following. Convert the following to the SI unit. Question 1. Let me write it on the blackboard. We are converting the SI unit of time. So question 1, 176 hours. Question 2, we are converting to the SI unit. Question 2, 4 days. Question 3, 4 hours and 50 minutes. Let's convert those ones quickly and we post our answers. Let's convert those ones quickly and we post our answers. Convert these ones quickly. Najida is telling us 1 century has 100 years. Thank you. Number 1, you cannot see the work on the blackboard. Number 1, someone is telling us you're not putting the units. The units to see what you converted it to. We are converting from, convert to the SI unit. We are converting the following to seconds. Okay. Ahura is telling us, okay, the answers are running very fast. Okay, you can see people's answers. You can't hear Nagawa. Okay, so for number 1, we see 1 hour. 1 hour had how many? 1 hour had how many?
1 hour had
3,600 seconds. Okay, so if there are 576, then there will be 576 times 3,600 seconds. So when you multiply using a calculator, very first what you get? You forgot a calculator. Okay, let's quickly multiply here. 576 times 3600. We get 2,073,600 seconds. How many were able to get that? For number one. Number one. Yes, very nice. I can see Azira has got it. Teresa has got it. Okay, let's go to number two, the days. How many days? I mean, how many hours are in, how many seconds are in one day? One day has how many seconds? First of all, we know we are number two. First of all, one day has 24 hours. Okay? One day has 24 hours. So the 24 hours, but 1 hour, but 1 hour has how many seconds? 3,600 seconds. So how about now the 24 hours? The 24 hours will be, okay, let me use my calculator here. The 24 hours will be that 24 times 3,600 seconds, okay? So when I multiply 24 3,600, I'll 86,400 seconds, okay? So that means one day has 86,400 seconds. How about now the 4 days? The 4 days would have 86,400 seconds, okay? Which will give us a 345,600 seconds. So this is what we have for number two. How many got the same answer? Very nice. Thank you, Elisha. Thank you, Shirat. People managed to get the answer. Thank you, Ainembabazi Vanessa. Okay, number two. How about number three now? Number three. Number three. Post your answers for number three. I can see people posting different answers. Teresa, the sec is not allowed. Please, you either write seconds in full or write a small s, but sec not allowed. I'm not expecting people to post answers with the word sec. Najwa. Don't post your answers with the word sec. It is either a small s or write it in full, like me. Okay? So let's try number three. So posted. So number three, they're telling us to change from 4 hours and 15 minutes. So let's first get how many seconds are in 4 hours and how many seconds are in 15 minutes. Then we add to get the total number of seconds. Is that okay? So 4 hours, we know that 1 hour is equal to 24. 1 hour is equal to 3,600 seconds. How about the 4 hours? The 4 hours will equal to 4 times 3,600 seconds. Okay? Which will give us, those with calculators, 4 times 3,600, 14,400 seconds. So now we have changed the 4 hours into seconds. So let's keep our answer. Now let's also change the minutes, the 50 minutes into seconds. So we know that 1 minute has 60 seconds. Very nice. 1 minute has 60 seconds. How about the 50 minutes now? The 50 minutes will have 3 times 60 seconds. Okay. Which will give us which will give us 3,000 seconds. So now can we add the total here for the hours and minutes? Let's add that to get the total number of. And when you add when we add, so we are adding 14,400 seconds plus 3,000 all in seconds to get the total 17,400 seconds. Congratulations to all those who passed it. Thank you, Shiba. Thank you, Mariam. Thank you, Roshanza, Wedde Grace, Habiba. You all managed to pass it. Now we can change, and also the other ones, okay? We can always change from one unit to another, okay? We don't want to waste a lot of time on that. Now, the other that we have to look at today, we have seen the different units of measuring time. We have looked at years, we have looked at months, seconds, minutes. Each of those units has a suitable moment when you're supposed to use it. Say, how old are you? I'm 100 minutes old. So we have specific units that we use to tell time in specific events. You cannot tell people that I'm 14 hours old. I'm 1,000 hours old, really. That will be too much. Okay, so we have specific units that we use to tell time for specific events. For example, quick question. What is the most appropriate unit to use when you're telling your age? Years. Okay. For your age, it is years. Thank you, Naira, also. Thank you, Karunji. Thank you. We can use years to tell our age. That most of the S1s are how old? What is your average in S1? 14, yeah? Yes. People in S1s, the average age is 14. Okay, so you cannot change, you have to tell in years that I'm 14 years. How about if you want to tell how long you would take to drink a cup of tea, which units will you use? If you tell someone how long you will take a cup of tea, what are the suitable units? A cup of tea. What are the suitable units to tell? Yes? Minutes. You can use minutes. Someone is telling me minutes, Husna. Thank you. Minutes, I think, are more suitable because you cannot take tea for hours. You can't take the tea for a day. That half a day or quarter a day to take tea. No, the most suitable seconds. You can take tea in seconds. Seconds, I think, is also too small because sometimes the tea is just use seconds to do what? So the most unit is second. How about which unit will you use if you want to tell someone the time the school assembly will take place? The time the school assembly will take place. Which units will you use? Thank you, Kamala. Thank you, Elisha. Hours. Use hours. Abigail, thank you. Daniela, thank you so much. We can use hours to tell that assembly will take place. What time does assembly normally take place at school? What time does it normally take place? Have you had assembly yet? What time does assembly take place at school here in Abisunsa? At 10. Thank you, Isabella. At 10:20, thank you, Birunji. We normally have assembly at 10, 10:30 there. 9:40. Okay, at around 9:40. How about which unit will I use if I want to tell someone the gestation period of a goat? The gestation period of a goat. Which units will I use to tell? Thank you, Bakia, Hannah. We use months, okay? We use months to tell someone the gestation of a goat. So we are saying that each of those units, we have seen the units are many, months, years, centuries, decades, but each of those has a suitable event to be used, okay? You can't tell me that I have spent 14,000 months in marriage. I've spent, each of those has a suitable unit, a suitable moment when to use them, okay? Someone said me the gestation period for goats, we can also use weeks. Even weeks, because even in pregnancy, even the ladies when they are pregnant, they can use weeks to describe their gestation. Thank you so much. Now we have an activity here. Before activities, what can we use to tell time? Any ways you know that you can use to tell time? What can we use to tell time? For you, what do you use to tell time? Because you've all showed me that you know tell time. Melissa is telling me she normally uses a clock. Maybe is telling me she normally uses a watch.
Even the sun helps.
Someone here is telling me that you can also use the sun to tell time. We know the sun rises, sets and rises. Is that okay? So we can also use the sun to tell time. Thank you. Someone telling me we can use calendar to know the date. We can also use a calendar. Catherine is giving me a very interesting answer. A shadow. Stars. Wow, people are giving me interesting answers. Someone is telling me a shadow. How I wish to get someone to help me describe how they can use a shadow. Someone is telling me position of the sun. Position of the sun. Mr. Mandala. Position of the sun. I want someone who gave an answer for the shadow to describe for me. How can you use shadow tell time? Someone to tell live audio. I want someone to tell me, someone who gave an answer for a shadow, how can we use a shadow to tell time?
We can use a shadow.
Is that your name, please? First say your name.
Karan Jishiba Ochanda from S1 East.
S1 is thank you, Karunji, yes.
We can use a shadow like when the sun has different positions it's in. So in the morning, sometimes the shadow can be long, so you can tell this time is in the shadow. At noontime, the shadow is like directly under you, so that's when you know it's noon. And the evening, it can be on your either left hand side, so you can know that it's evening. And at night there is no shadow at all, since there is no source of light in the sky.
Very nice, Karunji. Thank you, Karunji. Karunji is telling us that we can use the shadow to tell time because we use the sun. First of all, you have to go to an open area where you can easily see your shadow, okay? Where you can easily see your shadow. Make sure your shadow is not casting on anything, on a wall or on a tree. It should be casting down on the floor. So you have to stand in an open place where you can easily see your shadow. Now, Karun is telling us that in the morning, very early in the morning, like now, your shadow can down. So that means we use the length of your shadow till time. So in the morning, the length of your shadow is long. So as the day goes by, it goes on shortening, reducing on the length, reducing
Excuse
on
me, teacher.
length. Yes.
Good morning.
Good morning. Your name, please.
Asima Christine.
Asime who?
Christine.
Yes,
Yeah. So I would like to contribute to the shadow using the sun.
Okay.
You go in an open place. Like when you want to know that it's morning, when the sun rises, just stand like in an open place. Then when you see the shadow is short, that means it's morning. Then in the noon, it's shorter, as in it's under you. Then in the evening, it's long, very long.
Under me, it is exactly where I'm standing.
Yeah.
When I see my shadow exactly where I'm standing, then I just it is noon.
Yeah, that's noon.
Okay.
Yeah.
Then when
in
it,
the evening, it's very long.
on which side? On the same side where it began from in the morning?
No, any side. It can be in front of you in the evening.
Now she's in front of. Huh?
Yeah. Yeah.
Okay, okay. Thank you. All in all,
Yeah.
the technique is use the length of the shadow to tell time. Okay. We use the length of the shadow to tell time. So as it goes on shortening, you know that the day is. When it is exactly under you, just know it will be noon. It's almost under you, just know it is almost noon. Okay. That method may not be exact, but it can help you approximate. You may go for a camp somewhere in a forest or somewhere very far. And maybe you don't have watches, the phones are not working. And have is to use a shadow or the sun, the position of the sun to tell time. So there are situations where you have to use natural means to tell time. So that means you have to get the skill. Now the Muslims, we are all fasting, not so. When do we tell that now we cannot, it is fast? What do we normally use? What do we normally use? What do we normally use? What do we normally use?
Teacher.
Yes, yes.
Asima Christine again.
Oh,
Asima Christine.
Asima Christina again, you're the one still online, okay?
Yeah. The Muslims, like when they are starting their fast, they use the moon. And when the half moon appears, that's when they know. Then I think when it disappears, that's when they know they're ending the fast.
When it disappears. So that's when you. How about the unfasting time during the day? Because we wake up in the morning. Then later in the evening, we unfast. But which evening we unfast? How do we tell that now it's time to unfast to eat?
I'm not sure of it.
I'm not sure.
Yeah.
Okay, but okay, you're not sure. Other Muslims, I don't failing to get you. Okay, I want to check. Okay, let me see. The moon, sunsets. Catherine is telling me the sunset. You can use the sunset to see, to unfast. the moon. So the sun rises in the morning, and then by the time when it sets, that's when we do what? Someone's telling me adhan. They first wait for adhan, and when they hear adhan, they unfast. But then those people who tell the adhan, what do they use? I think they use the sunset, okay? They use the sunset. So that means we can use the position of the sun to tell time. And the Muslims, we do that all the time, to tell when to pray Maghrib, when to stop praying the early morning one, Subuh. So we normally use the sun, the position to tell time. Even the moon. Before we start fasting, the month of Ramadan, we wait for the moon. The moment we see the moon like this, the next day we have to fast. The same thing also on fast. We have to wait for the moon, because in Islam, or on the Muslim calendar, the moon shows beginning of a new month. Not so? We are the theology students to correct me. Najing. Najing. The moon shows beginning of a new month on an Islamic calendar. Not so? Yeah. So we use the moon, where the moment we see it, we know that's a new month. So we stop fasting. Is that okay? Thank you so much. Now in the laboratory, we all visited the laboratory here at school. We normally carry out some practicals, some experiments, but sometimes require timing. We have an instrument we normally use in the laboratory to tell time. We call it a stop clock. We call it a stop clock. We normally use it in the laboratory to tell time, okay? We call it a stop clock, and everyone's clock. We'll see it more when you come at school, but this is what we call stop clock. We normally use this stop clock in the laboratory to tell time. Can we all see the stop clock? Are you seeing that the dimensions on the stop clock? We have 60 here. Okay, so the red hand only has one hand, the red hand, and it's what we use to do what? To tell time. Maybe the other thing you should also know, that this stop clock only measures time in seconds. It will only tell time in. So in the laboratory, when you're telling time, your answers will always be in seconds. We don't have any instrument in the laboratory that we use to tell in months, hours, minutes, no. We use a stop clock, and the units the stop clock uses are seconds. So any time that we are going to measure using a stop clock, it should be written in seconds. Is that okay? So now, if you look at this stop clock, are you looking at it properly? Can you inside? It has 60, then as it moves like this, it moves in which direction? Which direction is that it's moving in? For those who can see it, which direction is it moving in? It moves in which direction? Clockwise direction. Clockwise direction. It moves in a clockwise direction. It has only one hand, that red one, that moves in a clockwise direction. So you can use it to time anything you want. We use clockwise. When it's circular motion, it's either clockwise or anti-clockwise, okay? So it moves in a circular motion. Well, if it's circular motion, it's either clockwise or anti-clockwise. So for this case, it uses a clockwise direction. Now, this stop clock, are you seeing? It has two, how should they call them? It has two, maybe let me call them knobs. We used to adjust the time. We have this long one and this short one. Is that okay? This long one helps us to take back the hand original position. The hand should always be at 60. Now, I was using it before to show you the direction. That's why it was moving and it had stopped somewhere. So if you want to use it again to time something else, to time another event, you have to take back the red hand back to 60. Is that okay? Back to 60. So to take it back, we use this long knob. So this, take it back like that. We use this long on this side to take it back. So the moment it starts moving and it stops somewhere, you have to take it back first before using it for another event. Is that okay? Then this short one starts or stops the time. If you want to start, you use it. If you want to stop, you also use it. So when it's down, then it has stopped. It is on stop. If you want it to start, you take it up. So now it has started. Are you seeing that the hand? Are you seeing the hand moving? It's because I've started it. The moment I take it, the moment I take it up, then it starts moving. So if I stop, I take it down like this. My hand stops. Are you seeing the red hand that it has? So when it stops, you then read that time. Is that okay? So it has two. It has one and this short one. This long one, we have said, it takes back the red hand, okay? The long one takes it back to the original position. The original position is always up. So when you're starting to count the seconds, make sure the red hand is 60. Is that okay? Then when it starts counting, then you can stop using this shorter hand by taking it back, down, then it stops. Is that okay? So this is what we call a stop clock. We use it in the laboratory to do our practicals, to time our practicals. Then we give you a certain practical that has an element. You have to record the time it took. Maybe you want water is boiling and you wanted to time how long it took to reach its boiling point. Is that okay? Maybe something was, you want to time. So each time you want to time in the laboratory, we use what we call a stop. The other way we can use to tell time is using what we call a pendulum bulb with a string to get a plumb line. Are you all seeing this? Okay. This one, the small ball, I think all of you have ever seen it in the lab. We call it a pendulum bulb. A pendulum. We call it a pendulum bulb. Some of you have never seen it in the lab. Jemima has never seen it. This one, we call it a pendulum. You can't see it. It's heavy, I can't. Okay. Are you seeing this? Pendulum, I'm going to write it on the blackboard. The ball, we call it a pendulum bulb. Okay. We call it a pendulum bulb. That's how we call this small ball. That's how we call this small ball. It's called a pendulum bulb. Is that okay? So we can use a pendulum bulb also to tell time. Still in seconds, we can use this to tell time, but still also in seconds. Is that okay? So what do we normally do? We get a string. Okay. This is a string. We get a string. We get a string. String. Are you seeing the string? Okay. We get this string. We tie it on the pendulum. I want it a little longer. I want to adjust. I want to adjust that it becomes a little longer. Oh, when I over adjust it, you won't be able to see. So let me take it back to where it was. I think there you can see, okay? So there you can see. Now we tie it back. This one we call it a clamp, okay? This metallic thing must hold this one in the laboratory. We call it a clamp. It helps us hold anything you want in the lab. It can hold anything, a ruler, maybe if you want to measure, okay? If you want to measure maybe length of this string that you have used, we can use a ruler to measure the length of the string, okay? So this one is called a clamp. We can use a clamp in the laboratory to help us hold anything that we want. To help us hold anything that we want. So we are saying, how can we use a string and a pendulum bulb to tell time? And we are saying in this case, the only units that can be used are seconds. Is that okay? The only units that are used here. How do we tell? You can use it to time any event. Maybe someone is running around the field and you want to time the number of seconds it took to run around the field. We can use it. We can use this, and it will give you the same answer as any other instrument that you. For example, here I have a stop clock. Someone may have a watch, anything that you can use to time. You get the same answer when you use this pendulum bulb in seconds. So for me, I'm going to use both a stop clock and a pendulum bulb to time and see if I can get the same answer. Is that okay?
What if you get different answers? What causes the different answers?
Someone is asking, what if you get the different answers? What will cause difference in the answers? I think it will be an element of inaccuracy. Maybe you started the stop clock a little late, or maybe you're not swinging your pendulum properly. An element of inaccuracy, but they're approximately supposed to give you the same answers. Is that okay? They're approximately supposed to give you the same answer. So how do you use this pendulum? This pendulum, you can swing it, adjust it a little, not too long, but a little, and leave it to swing. You have to put it in a place where it can easily swing, okay? It can swing freely. You have to put it in an area where it can swing freely. Don't put it. You have to put it somewhere where it can swing freely. Okay, like here. So each time it moves, it goes, comes back. Each time it moves side by side, that's a second. Okay, that is a second. Let's see. If it goes the other way, that will be 1 second. If it comes back my side, it will be another second. Goes the other side, becomes another second. Comes back here, it will be another second, like that. Is that okay? That's right, my string is not properly tied here. Come. Let me tie my string properly. Put it in between. Then adjust there. Open it. I sewed it properly.
But I think it's low.
It's too low, they can't see.
Yeah.
Okay. Right. How about the tie now? So we are saying we can use a pendulum to tell time. Each time it goes the other side, it will be a second. Come to the other side, it is another second. Each time it moves side to side, it will be another a second, okay? So when it goes there, 1 second, 2 seconds, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So each time it moves side by side, it will be a second. So now I want to create an event here. I have, what's your name? Josephine. I have Josephine here. I want her to run from one side to another. From one side to another. How many laps? Let's give her 5 times, and we time her to see how long she takes, okay? To run 5 times from one side to another. From one side to another. 5 times. I'm going to use a pendulum bulb, and I'm also going to use a clock at the same time. And I'll see at the end of it all, am I getting the same answer? Am I getting the same answer? So Josephine, I start from the other side. Make sure you don't fall down. So first wait and we begin. So we set our stop clock when you're starting to time. Make sure the red hand is exactly at 60. So is it at 60 now? Are you all seeing 60? Okay. Are you all seeing it at 60? Yeah. So people are seeing it at 60. That is the beginning. Before you use it, it should always be at 60. Okay. So when I'm starting to time, I don't know how I'm going to handle both this one and the timing. Okay. But I'm going to start this one, leave it here for you people to start timing. Me, I count here. Okay. So each time the pendulum goes the other side, that is a second. That's another second. Is that okay? How I wish. Is Mr. Namdala there? Is it? No one is there? Yeah. Okay, it's okay. We'll do it ourselves. So 1, Chelimo, you're going to run, Jose, you're going to run it 5 times. Okay. 1, 2, 3. Start. 1, 2, 5, 6, 7, 8, 9, 11, 12, 13, 14, 15, 16, 17, 18, 21, 22, 23, 24, 25, 26, 27, 28, 29, 31. You have stopped. You are fine. You have not yet stopped. So here it has stopped at around 28. The reason why it's like that is because I'm one person. I couldn't time both at a go. I can't be perfect. I had to swing this one. I also had to start and begin this one. If I had more people to help me here, I would get exactly the same. So here I've got around 30. Here it's 28, but there is that delay. I had to stop and also stop here. So someone, Jemima is telling me for her she got 33. For using the string, Jemima. Okay, so Jemima, when she counted using the string, she got 33. Okay, so maybe I swing, people count using the string. For me, I count using so because we are supposed to get the same time. Is that okay? So Jose, we're going to run again. Okay, I'm going to begin the moment. Let me swing it, but the moment she starts running, you start counting. For me, I will use the stop clock. Is that okay? Wait, just marks. Get set, go near marks, start. People start counting the other one. 13, 14, 15, 16, 17, 18, 19, 20. You have stopped. You were 5 that fast. Anyway. What time did you get using the pendulum? Someone got 23, others 21, others 20. For me, I have 18. Okay? For me here, 18 my what? On my, but the more you try it on, time getting the same answers. Time comes the same answers. Thank you, Chief. So we have looked at both, at a pendulum, how we can use it to tell time, which we'll also be getting in the laboratory when you come to school to do your practicals. Is that okay?
Yes.
Now, the time we get using the pendulum, that time that you've got using the pendulum, we can call it estimated, okay? Because it may not be exact, it may not be accurate. That's why we are calling it estimated time. So if you want to estimate time, like the way we estimate using a shadow, estimation means it is not accurate, but you're estimating. Yeah? Another word for estimating, it is not accurate. Is that okay? I made you. Okay.
Excuse me.
I wanted to mute. Okay. So we are saying that the time we have recorded a string and a pendulum, we call it estimated time. Then the time that you have recorded using a stop clock, the time that we recorded using a stop clock, we call it actual time. We call it actual time. So when you're recording time for an event, you have an event here, the estimated time, and the actual time. Okay? So when Jose was running, the time that we screen, which some people got as 22 seconds, was estimated time. Then the time we got using a stop clock, which was around 18 seconds, was actual time. Is that okay? So if you want to get time, you have to use a stop clock in the laboratory. If you're getting time, you can use a pendulum. Okay, but in the long run, the more activities, in the long run, you'll find that the estimated time will now be the same as the actual time. They will be exact, they will match. Is that okay? They will match. Time will come when you're getting the same values, using a pendulum bulb and using a stop clock. Is that okay? Now, the other thing that we can get from time, in physics, called period. Okay? We have what we call period. Another quantity in physics that is important, and we can also obtain it in the lab using a pendulum bulb and a string, the same way we were doing it. We also use it to get period. How do we get period? Period is got from time. If you have in seconds, time in seconds, you can get period by getting time in seconds divided by number of oscillations of the pendulum bulb. Pendulum bulb.
Excuse me.
Yes.
Can you please explain the meaning of
Oscillation. Someone is telling what is oscillations. Oscillating is that swinging of the pendulum side to side. We use the term oscillating to mean that movement of the pendulum bulb that you saw side to side. For example, if I put it back, when I swing my pendulum bulb like this, it is oscillating. That is what we call oscillating, and it's making oscillations. Is that okay?
Yes.
It's making oscillations. If I want strictly 20 oscillations, I let it swing 20 times. I let it swing 20 times. That's when I want maybe 20 oscillations. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 16, 17, 18, 19, 20. And the moment I reach my 20 oscillations, I stop it. Okay? I was letting my pendulum swing 20 oscillations. So we're saying if you're getting period, if you're getting period, you get that time that you using a stop clock divided by the number of oscillations that your pendulum has taken to get what we call period. So if you're getting period in the laboratory, you need a stop clock. We will need a stop clock. We will need a stop clock to give us the time in seconds. We also need a string and a pendulum to swing side, make the number of oscillations that you want. Is that okay? Yes. 1, 2. Those are seconds. Josephine is asking me, how about when it swings 1, 2, 3, 4? That one is making seconds. Okay? It is recording time in seconds. 1, 2, 3, 4. That one is seconds. But oscillation has to swing and come back. The way you swing, you go and come back. That is one swing. You go and come back. That's another swing like that, like that. Is that okay? Please, you can post some questions just in case you have. You can post some questions. So I can get period of maybe 20 oscillations, okay? I want to get the period of maybe 20 oscillations. So you're going to record time. You're going to get us time in seconds here. So the moment it starts oscillating, you start the what? Have you start and stop? Then for me, I'll swing so that we get 20 oscillations and we get the period. Is that okay? So I'm starting to swing my pendulum. It does not stop on its own. For it until it is up to you to swing, to stop it. If you want it to stop, you simply hold it. You can let it swing. Then if you want it to stop, you simply hold it and it stops. For as long as you've got your desired number of oscillations. Is that okay? Movement of a pendulum, make sure you give it free space where it can swing freely. Okay? It should not stagger moving like this. Make sure it can swing, go and come back, go and come back, go and come back. Make sure it does not hit anything. Okay? Because the moment it hits something, it can disrupt its speed, its direction of. Apia, welcome, Daddy, for me. Daddy is also attending. Okay, so are we ready to get that period now? Yes. Are we ready to get that period? How many now with me now? Daddy, you're welcome. Daddy Apio. Okay. So are we ready to get the period now? Okay, people are with me now. So we are going to get period. We are going to swing our pendulum for it to make 20 oscillations. And Josephine will give us the time it took to make that 20 oscillations. Is that okay? Yes. So these are the oscillations. We said oscillation is the swinging. When it goes and comes back, that's an oscillation. When it goes and comes back, another oscillation. Goes and comes back, another oscillation like that. Get ready, Joseph. 1, 2, 3, go. 1, 3, 4, 5, 6. Hit something. The moment it hits something, then it will be invalid, okay? It will not be accurate. You have to swing it properly so that it doesn't. By the way, you don't need to adjust a very big angle, no. So it will go slowly. It will not go slowly, but if you use a big angle, it will start doing those, the way it did. Okay, so you need to adjust it properly at a desirable angle, not too small, but not too big. And then you start swinging it. Gently, you need to be gentle. Don't use a lot of energy. Is that okay? Don't use a lot of. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. What time did it took? It took long to stop. Hey, you were busy. This one took long to stop. Who else was timing? Maybe using a watch or, So she has 30 seconds. Okay? Jose has got for us 30 seconds. So to get the period, that time in seconds will be 30 divided by the number of oscillation. The oscillation is what? 20. So when you divide 30 by 20, you get, what answer did we get? 30 by 20. Someone got 20, someone here got 20 seconds. People are telling me they got 20 seconds. Are you sure? Someone got 20. Okay. So when you divide 30 by 20, 10 remainder 1. So people have got 1 point. People have got 1 point.
People unmute yourself. Unmute yourself.
30. You get 1.5. Thank you. Thank you. Thank you. People have got 1 point. So the period in that case will be 1.5. So in these remaining minutes, we have looked at time. We have looked at the S units of time. We have also looked at the other units. People have given us very many other units. We can use to tell time. We have also looked at ways we can use to tell time. We have the natural ways like the position of the sun, the shadow, the moon. We also forgot animals. Animals can also help us tell time. Anyone who has an idea of an animal that can help us tell time and how? Be an animal or a bird. How can we use animals to tell time? We can also use animals to tell time. How can we use an animal to tell time? Post your answers and I see them. Post your answers and I see them. How can we use animals to tell time? Can you chat? Post your answers. Post your answers. Post your answers. How can we use animals? Example of an animal that can use us to can help us tell time. We don't have farms at home. Those are old. She was telling us a cock. We can use a cock to do what? To tell time. A rooster. What is a rooster? Huh? What is a rooster? I wish Martha would explain for us what a rooster is and how we use it. A cock crow. Hey, Helen is telling us we can use a cock crow. What time does the cock do what? Crows.
Cry.
Cry, no, not cry. Yeah? And what time does that cock make that noise? Naji, don't you know? Crows, yes. What time does the cock crow? Yeah? The cock crow? 6 a.m. A male chicken is a rooster. Oh, thank you. A male chicken is a rooster.
In the morning.
What time? Even now it's still more.
Early in the morning, like at around 5, 6.
At around 8. It has a specific time. It doesn't have around 6. Someone is telling me to cross at 6. Others are telling me at 5. Someone else gave me information cross at 4 a.m. 4:30. 4 a.m. Yes, question.
Can we use a stopwatch for measuring time?
A stopwatch.
Yes.
Yes, we also have instances we use a stopwatch in the laboratory to measure time.
Excuse me, teacher.
Yes. Who is your name?
Excuse me, teacher.
Yes, your name.
Camping.
Yes.
Teacher, for the pendulum bulb, how do we count the oscillation? Like if it goes on both sides, do we count the movement it makes on both sides or we count for one side?
For the oscillation, we count one side. The moment it swings and comes back, that's an oscillation. Swings, comes back, another oscillation like that. It goes, I'm showing you once more. Go 1, 2, 3, 4, 5. You have to wait for it to first go and come back. Go and come back. That's how we count the number of oscillations. That was time. A physical time. When are we meeting again? I think we'll meet again tomorrow. We are going to look at volume because we want to move at density. So whether we covered volume or not, we are all going to look at volume. You see how to get volume. So come when we have some information about volume. We have some information about volume. So come when you're ready to study. For those who have already studied, get ready to give us some ideas, to give us some answers. Have you calculated? Did you get it in the lab? Then from volume, that's when we'll move to density. Then we'll clear the measurements. Previously, I think we have all looked at length with your previous teachers. We looked at length, the units you use to tell length, the instruments we use to measure. You must have all looked at area. You look at area, do you know how to tell area, how to calculate area of both regular and irregular objects? Then from there, you must have moved to mass. You must have measured mass. You know the instruments to measure mass. Have you looked at them? Have you looked at the instruments? We have them in the laboratory. You get a chance to see them in the laboratory. We have the instruments we use to measure mass. So maybe when I'm looking at density, I'll have to bring back some instruments we use to measure mass because we'll need them, mass and volume, to get to density. It was a nice day with you today. Get ready for me tomorrow. Get ready for me tomorrow.